Welcome back to the Counterman Education Center. Today we are going to explore a fascinating topic, the topic of turbochargers. It's not new, but in recent years it's taken on an entirely new look. Stick around and we'll get into the current spin of turbos. In the past, a turbocharger was considered a high-performance piece of equipment. Today, however, it's becoming far more commonplace, and with good reason. When you consider that a normal internal combustion engine operates at a 20% thermal efficiency, there's a lot of fuel energy being wasted out the tailpipe. A turbocharged vehicle uses some of that wasted energy to increase performance. We'll look at how in a minute. A non-turbocharged 4.6-liter V8 produces 270 horsepower, while a 2-liter 4-cylinder turbo engine produces 272 horsepower. That's a little more horsepower with less than half the displacement. Those numbers are very impressive. Now let's look at how a turbocharger operates and obtains those gains. Turbochargers are a type of forced induction system. The turbocharger is typically placed somewhere in the exhaust system. Exhaust gases turn a bladed fan, sometimes called a turbine wheel. This is connected on a shaft to another bladed fan that is called the compressor wheel. This side of the turbo pulls in outside air to force it into the engine. This compressed air then travels to a cooler that lowers its temperature and increases its density. Remember, cool, dense air is better for fuel atomization and eventual combustion chamber efficiencies. To really understand a turbocharger, it's important to be familiar with its components. The turbo is divided into two sides. One side of the turbo is the hot side. That's the side that's handling the exhaust gases. This side is comprised of a housing, a turbine wheel, and a backing plate, and an important set of bearings. In the middle of the turbo is the shaft that runs through it and a series of oil passages. On the other side is another bearing and the compressor wheel. This side is considered the cold side. If all that heat wasn't enough, the entire fan and shaft assembly can spin as high as 200,000 RPMs. A turbocharger can use a wastegate to limit output by regulating intake manifold air pressure and preventing overboosting at high engine speeds. When the engine wastegate valve is closed, all of the exhaust gases flow through the turbine wheel. When intake manifold pressure near the maximum boost level, the wastegate actuator opens the valve, diverting some of the exhaust gases away from the turbine wheel, limiting turbine shaft speed and air output from the compressor. Join us in part 2 when we'll investigate what makes these fantastic machines fail and how to help your customers when replacing one.